we kind of picked up everything on the third generation. The third generation, remember, is pretty close to what was in 2.5G. There's a couple differences. The biggest difference was the air interface. And then there was this optional architecture that was released, or that was offered in release 5. So then things got really kind of confusing then, because you had this part of the network which was circuit switched. When we say circuit switch, we mean things that circuit type of services. Voice is a circuit type of service, a traditional voice. Short message services, circuit switch service. But you also had a network for packet switching, which were these GPRS serving GPRS support nodes and gateway GPRS support nodes. And these were data tunnels that were formed here. But there was this optional architecture called the IP multimedia subsystem, meant to bring in IP, Internet Protocol type services, into the mobile environment. That was the idea back then. So this is all going on now. We have these different releases, and that started on release 99, then release 4, then came release 5, 6, and 7, and that was all 3G. Starting with release 8, the architecture changed to LTE, and that stayed up through release 14. So release 8, 9, 10, this was roughly the time frames. Release 15 was a new generation, 5th generation. So that we know there was motivations for this 5th generation. Data, especially by the mid 2000s, 26, 27, 2007, 2008, there was much, the data was increasing tremendously. Plus you had all these 2 different radio networks, 2 different core networks. It was kind of hard to maintain that type of thing. And then there was also things like the standards were becoming very complex. The standards were becoming extremely complex back in, by that time. You had different packet access and so on. So there was a need for more modulation, better modulation, more efficiency, more spectral efficiency. Again, that radio spectrum is a very precious resource, and it has to be used very efficiently. So the whole idea here was to change the architecture and change it from circuit switch to packet switch. So starting in 4th generation, there's no more circuit switched. Now we still have circuit switched services. You can still use it for voice. You can still use it for short message service, but it has to be handled differently now, since the networks were all IP. So your user equipment the RAN, the radio access network, and then the CN, the core network. So the user equipment was still called user equipment in 4th generation. Your base transceiver station, which was handling your circuit switch on the radio side, and your node B, which was handling your 3rd generation. That you had basically 2 different types of radio, and they were being controlled by the radio network controller. And then that all of this got combined into one unit, which was called the enhanced node B. Now, why they named it the node B, the enhanced node B, in 5G is called the NG, the next generation node B. I don't know where they get these names from. But anyway, instead of a separate radio network controller, because you don't need a radio network controller, you're not splitting circuit switched and packet switch, it's all packet. So this becomes your enhanced node B. That's your RAN, your radio access network. And all of these things that were on the circuit switch world, you had all of these devices on the circuit side, you had all these 2 devices on the packet, that all became part of what's known as the Evolved Packet Core. And so let's take a look at that Evolved Packet Core, that EPC. So your core network is now called the EPC. And this is the Evolved Packet Core. So your user equipment, of course, is here. And that's not just mobile phones. That could be smartphones, laptops, tablets, Internet of Things devices. Your base station is now, like we said, is called the E node B. And this is your core network. And it's made up of a different architecture than we saw with mobile switch and VLRs and EIRs and HLRs and all these other devices that we saw earlier. Now it looks like this. You have a device called the Mobility Management Entity, and it does exactly what it says. It manages the mobile. It's the control device that manages the mobile. It manages the authentication of the mobile. It manages the updating of the location, manages the system. So it knows everything about every mobile in the network. It communicates with the legacy equipment identity register. Remember, the equipment identity register houses your hardware identity. And that's called your IMEI, your International Mobile Equipment ID. That's like the hardware identity of your mobile phone. Then you also have the HSS, the Home Subscriber Server, which is very similar to the Home Location Register. It's basically a next step up from a home location register. It's called the HSS, the Home Subscriber Server. So that's the HSS, and that communicates with the mobility management entity. So the mobility management entity will update your location to the HSS, and the Home Subscriber Server, just like the HLR, has a copy of your profile, a copy of all of your services, and it also knows where you're at. It knows where you last did your update location. So any service that needs to find you will always go to the HSS first. You also have a communication path down to this serving gateway. And the serving gateway, think of it as a kind of an evolution to this right here, to this serving GPRS support node. Kind of the same thing. So instead of a radio network controller, you go right from here, but you communicate with this serving gateway, which is like the SGSN. And then you also have a PDN gateway, a P gateway, which is kind of like this gateway GPRS port node down here. So the new serving gateway and the new PDN gateway, packet data network gateway, are kind of like these two devices here. So this is your network. You have another device here, another entity, and it's kind of a strange name, policy and charging rules function. You can apply, since this is all data, you can have different what are known as quality of service. You can apply different quality of service, um, uh, basically the functions to different data streams. So you can apply different policies to different types of data streams. You might have let's say you're using your mobile phone to just to go on the internet. Well, that's like a best effort as far as the guaranteed bit rate. It's not going to give you a real high quality. If you're using your mobile phone for voice over IP, it's going to give you a higher quality. It's going to give you a higher latency, your latency, your jitter, your guaranteed bit rate, those types of things that make up quality. Those qualities are called policies. And so policies and charging rules are given from this device down to here. And this is the enforcer. This enforces the policies. When you access the network with 4G, you're always on. In other words, a 3G system, you can still use your mobile phone to place phone calls, and if you're not using it for data, you don't have an IP address. You're a mobile phone. But in 4G, it's 100% data. So you're always on. As soon as you get access to the network, you're assigned an IP address by this device here. The P gateway will assign an IP address to the mobile, because again, you're always on a 4G system. So these are the major entities in a 4G system. Very, very much different than second and third generation. Also, when it shows kind of like this, a flat architecture where you have a mobility multiple towers can communicate with multiple mobility management entities. They communicate with the HSS, and there even can be physically multiple HSSs. These MMEs can communicate with different serving gateways. Again, depending on architecture and geography, it's all going to depend on that. And you can have multiple P gateways going out to various networks out here. So it's not strictly like it shows here, just one of these entities. You can have multiple of these entities. So you connect to more than one node with 4G. Is kind of just what we described. Let's take a look in a little more detail. And this, of course, is your user equipment, is your smartphones, your laptops, your tablets, and your EU-TRAN. With the whole thing is called the Enhanced UMTS Terrestrial Radio Access Network. Kind of a long an acronym within an acronym. The actual base station itself is called the E Node B. The enhanced Node B was called Node B in 3G. Now it's the enhanced Node B. And the overall architecture for the RAN, the radio access network, is this EU-TRAN. So again, everything is controlled here on the RAN side. The controlling device is called the MME, the Mobility Management Entity. And here's what it's responsible for. It's responsible for the mobility of the mobile. It's responsible for the session. It's in the control piece of it. It's the element that controls everything. It does manage your authentication. Again, the system will authenticate you many times. You don't know that it's happening, but whenever you place a call, it might want to authenticate you. Whenever you receive a call, it's going to first authenticate you. And again, it's going to vary how often it does that, but it can authenticate you anytime it wants, and it'll just say, "Hey, I want to prove to me who you really are." In 4G systems, and start in second generation systems and GSM, the network authenticated a user. Starting in 3G, it's a mutual authentication. So not only does the network authenticate the user, but the user authenticates the network. It's a mutual authentication. But it's under control now of the mobility management entity. It understands many protocols. We'll look at that in a second, but it's a separate protocol that goes from these two. It's a separate protocol here. It's a separate protocol here. This is called S1AP, application protocol. This is diameter. This is GTE. So again, there's a lot of different protocols it has to understand. And it can, for backward compatibility, if you need to connect with other networks, maybe legacy networks, to do any kind of interworking network to network, it's MME to MME. So you also have this, the equipment identity register, which is just like the legacy equipment identity register. It lists all the valid equipment. Yeah, sure. Yeah, question. In fact, let me open up my chat window just so I can put up this so I can see. But anyway, yeah, is there a question, please?
Yes, please. You mentioned in the 4G architecture, the user authenticates the network, and the network also authenticates the user. I want to ask, how does the user authenticate the?
It's by I'd almost have to do a separate slide and shows you that, but the values that are given down from the network to the user to the mobile equipment, those values to authenticate that this is really a valid network. There's a call flow, and I've got those on different slides. I'll see if I can come up with the slides that show exactly how that works. But it's when the network commands the mobile to authenticate, it gives it certain values that the mobile then uses those values to authenticate that this is really a true network. And that's to prevent things like MC catchers. These MC catchers are phony base stations that fraudsters will put up to try and get your mobile to attach to that phony station. So it's now a mutual authentication. I'll see if I can come up with some slides that show exactly how that works. It's kind of a confusing back and forth, but I'll show that. Okay.
Yes, sir. Yes, please.
Okay. Very good. In fact, let me make a note of that. Hold on one second. Let me make a note of this. Slides on mutual authentication. Yes. RRC is radio resource control. Those are protocols over the air interface. RRC type of protocols are just protocols that are used now on the radio on the air interface. Is that the question, RRC? Yeah, okay. Yep. Um, Okay, the policy, and we'll look a little more at policy. This is the source for policy, control, and charge. And again, we'll take a look at a little more detail on that. HSS, the home subscriber server, is just like the HLR. It's the database for the subscriber information. Again, very similar to the HLR. It contains the user's identities, the subscription information, the security information. Authentication is done in the. It was a separate device called the AUC, the Authentication Center, in 2G and 3G. They've combined that into the HSS. So the home subscriber server is not only what the HLR did, but it's also what the Authentication Center used to do. So those are kind of combined right now. And then the P gateway. Well, let's look at the S gateway first. The serving gateway routes and forwards your user data. It's also used for any inter handover. When you go from if you're moving, you go from one cell, let's say you're moving this way, and you now go to another cell, it's responsible for handover. It's responsible for coordinating the handover from one cell to another cell. So it's the inter handover coordination under control usually of the MME. It's also done for lawful. It's also where any lawful intercept. Many countries allow, with court order, intercept. So for a lawful intercept where they want to listen in or whatever it is, I'm not familiar with it, but there is such a thing as lawful intercept, and this is the point where they would intercept your traffic, because this is where your user data goes. Your user data is going to go over the air to here, and it's going to go through a GTP tunnel here, kind of like a VPN. And it's going to go through a tunnel here, and it's going to be handed off to the world through these tunnels. So the PDN gateway, now this is your access into the world, into the packet world. It connects the evolved packet core to the external IP network. It also gives the user equipment its IP address, and it's the policy enforcer. So these are the kind of the high level look at all the piece parts of a 4G system, and it has the name LTE. It was really the evolved packet core, but everyone calls it LTE. Questions on this? Any questions?
Yes, please. Yes, thank you. So with the circuits switches, you
The circuit
mentioned
switching, yes.
yes, you mentioned that the mobile switch was responsible for the handling, where a user is moving from places to places. So the MSC was responsible for the handovers. So can we say in this case that the serving gateway is the same as the MSC?
Really, the MSC is more what this is doing right here. What was the mobile switching center in 2G and 3G is really, and remember that was a combination of the mobile switch and the VLR, the visitor location register. Those two kind of because the visitor location register was within the mobile switch. So those two functions together are now handled right here. This is more of what the 2.5 and 3G had, the serving GPRS support node. And this is more the gateway GPRS support node. Because remember, this is packet only now. So there's no circuit. So we're going to talk about that in a few minutes. Next, we're going to talk what do you do with circuit services. But remember, this is 100% data, 100% data and data only. So voice calls are not included in here. Short message service is not included in here. Your normal circuit type of services would not be part of this network, but yet you still have to handle them.
I was asking because I was trying to find a way if there was any similarities between the architectures, the circuits and the packets, whether there were any similarities between them.
Not sure I understood that all, Raphael. Can you?
Yes, I can you hear me, please? Hello, Steve, can you hear me?
Yeah, I can hear you, but it's just not coming in real clear. But go ahead, try that again.
All right. I said I was asking to know if there was any similarities between the circuit switching and the packet switching, especially with the seven gateways and the external to know if like they are
No,
partialized.
no, there's no similarities on the circuit switch here at all. The only similarities on the serving gateway and the P gateway would be the serving GPRS support node, the SGSN, and the gateway GPRS support node, the GGSN. So these two functions right here, the closest they are these things right here, back in, are these things down here, because all of this is out of the picture now.
Yes,
So
sir.
there's really no similarity on those at all.
Yes, sir.
Does that answer the question?
Yes, sir. Yes, sir. Thank you very
Okay,
much.
good. Yeah, absolutely. Go ahead, please. hmm Um, well, the different with the idea of the policy and charging rules function is you can apply different values to different data streams. In other words, you can have multiple data streams going at the same time. You might have a data stream going here, and you're communicating www cellusisacademy.com. So you're out on the internet. You might have at the same time a data stream because you're talking voice over IP. So you can have different data streams open at the same time. The idea of policies is that you can treat different data streams differently. You, okay. Does that make sense? Does that answer the question? Oh, I don't hear you there, Raphael. You're muted. Okay, I didn't hear that first part. Did you? Okay, good, good, excellent. Okay, I don't want to get too much into this. This is just a lot of acronyms, and I wanted to include it only because there are some different identities in. Remember a long time ago, a couple months ago now, we talked about different identities. That the mobile networks have. Well, there were some different identities for the mobility management entity, and it comes down to this GUMMEI. This identifies one unique MME. So these devices here are very unique in the world, and it really comes down to all of these. So rather than just read through these, just be aware that the mobility management entity is identified this way, unique, and it identifies one mobility management entity anywhere in the world. And there's also identities for the mobile. The mobile, when you power onto the system, it gives you the system gives you a temporary identity. Once it knows who you are, once the system in the second and third generation networks, once it knows who you are, you've given your MC, your international mobile subscriber identity. The system comes back and says, don't use your MC anymore, because I don't want you to say that over the air. I'm going to give you a temporary identity called the TIMC, temporary mobile subscriber identity. And it's just a 32-bit number. Well, kind of the same thing here, but what it does is it gives you this number right here, this GUTI. The GUTI is your globally unique temporary identity. So now you're known by GUTI, and instead of giving out MC who you really are, you get that GUTI. So again, I just wanted to bring up those two things. There's identities for the MME and there's identities for the mobile. Now, one of the big changes on a lot of big changes on 4G. Number one is a flatter architecture. Number two, it's all IP. Number three, the protocols change. There's no more SS7. The communication between the mobility management entity and the equipment identity register and the mobility management entity and the home subscriber server and the policy and charging rules function and the P gateway, that's a new protocol called Diameter. Diameter it's what's known as an AAA, an authentication, authorization, and accounting protocol. It's a protocol written by the Internet Engineering Task Force. It's a very simple request answer protocol. Hey, give me what I want, here it is. Hey, give me what I want, here it is. So it's kind of a simple protocol, but SS7 is out of the picture now. SS7 was there in second generation. SS7 was in third generation. Everything in circuit switch was SS7, but now we use diameter. The other protocol is GTP, GPS tunneling protocol. So user tunnels are built from here to here. User tunnels are built from here to here to access the outside network. This is GTP, but it's just a control part of GTP. GPS tunneling protocol is made up of control plane and user plane. The user plane is the actual data tunnel. Think of it like it's like a VPN. It's like IP security. It's where you build a tunnel and then you carry your packets basically inside the tunnel. Now, again, it's not a tunnel like we say. It's just conceptually, it's easiest to understand that way. It's a packet within a packet. So you'll have an IP header, and then you'll carry data right after that. So these tunnels get built here to here and here to here. Um, it's the same as we saw in 2.5G. It's the same as back here. If I go back to the second generation, third generation, that was GTP between the radio network controller and the serving GPS support node. And it was GTP. That was a tunnel between the serving GPS support node and the gateway GPS support node. So same tunnels, same types of tunnels, but now you're building them between the E node B to the S gateway and the S gateway to the P gateway. So that's your that's your newer protocol. But this is the newest protocol now. But that new protocol was called the IP. It was called Diameter. Questions on that? Yes. Yeah, Benjamin.
I just wanted you to voice about something you had said in the past. The 4G, the primary architecture for the 4G, you mentioned it's a flat architecture. There's
Yeah,
an
just
IP
more
chip.
of a instead of multi. Yes, it's kind of a. I don't know if that's the correct term, but yeah, it's kind of a flatter architecture. Yep.
There were three, so I wanted you to go over them again. The IP change and things like that.
I'm not understanding that last part where you
So you
I don't know if
said
it's your.
you said that there are three main things with the 4G architecture. The first one is a flat architecture. Then there's an IP change, but the third one I did not get. I was just asking that you voice about it again.
There's a lot of echo there. Help me out, Raphael. Well, maybe flatter is the wrong thing. It's just kind of a almost a one-dimensional type of architecture. You don't have a circuit architecture and a packet architecture. It's just kind of one architecture. I guess that's probably the right way to say that. It's all one simpler network. It doesn't separate the circuit switch from the packet switch. It's just everything's data. 100% is data. I think that's more what I meant to say. Hopefully I didn't, that's what I was implying there. Yeah, G diameter is a kind of a replacement of SS7. So diameter is doing things like authentication, location updating, any changes to your profile are done with diameter. Any type of communication between the mobility management entity to this HSS now, instead of being SS7, that's diameter. It's just a different type of protocol. GTP is what's referred to as a tunneling protocol. Now, it doesn't mean that you build a tunnel, but what it means is that you route something with an IP and a port, but then within there's a separate IP and a port. In other words, if this mobile here is addressing a IP over here, this is the destination, this is the source, but it's carried through a tunnel that has a destination and a source here. And that's carried through a tunnel here that has a destination and a source. So it's equivalent to what the GTP is doing. Just think of it like this. Think of it like I'm going to write you a letter. So I write you a letter, Raphael, and I address the envelope and I put the letter inside the envelope. Okay, now just picture that. I write you a letter and I put it inside an envelope, and the envelope I put your address and my return address. Okay, I take that whole thing and put it inside of a FedEx envelope, and I route this thing through the FedEx, even though inside there is the letter that you're going to have. The GTP is the FedEx. Inside of that GTP is the actual letter that's going from here to here. That's what GTPs does. It's the same way that VPNs work. It's the same way that IP security works. It's the same way that generic routing encapsulation works. These are what are known as packets within packets. And the biggest reason is mobility. As you move from cell tower to cell tower to cell tower, you don't have to keep getting a new IP address. You keep your same IP address. The tunnels change, you don't change. So that's the biggest reason for GTP. Does that make sense? Yes, that's under control of the MME. The mobility management entity will instruct through this interface. It instructs the serving gateway to set up a user tunnel here, and then a user tunnel gets built here, and a radio bearer gets set up here. So whenever you power on, you get an IP address. When you power your mobile phone on in 4G, you're connected. It's an always on experience. So these tunnels automatically get built, and this tunnel automatically gets built, and that tunnel automatically gets built. Now, if you don't use your mobile phone for a while, let's say you keep it on, but you go to bed at night, it tears down the radio and it tears down this tunnel. It keeps this tunnel. In case data comes in for you, if data comes in for you, it'll rebuild this and rebuild this. It doesn't hold the radio up all night long while you're sleeping or while your mobile's idle. Makes sense? Absolutely. Okay, we'll start on Friday. A couple of things we're going to talk about on Friday. We're going to look at interconnection, and we're going to see, okay, what about these what about these circuit services? Because circuit services have to be handled now, even though it's a packet only network, you still have to handle circuit services. So how do you handle circuit services in an all IP network? That's what we'll talk about on Friday. Okay, everyone, enjoy the rest of your time.